So we're going to go over the 5.4 section, chapter 5, section 4, homework. And this one says, choose the method that we might think will work on finding the antiderivative of these. So x sine x is one that substitution does not work on, but integration parts by parts does if you let u equal the x and sine x dx equal v prime. So this one's by parts. This one, if you let u be that denominator, the derivative of it will produce a 2x, just kind of show you this, equals 1 plus x squared. Du would equal 2x dx, and so we get in solving for dx, we get 2x under the du, and that would cancel the x when we make that substitution for dx. And so that one will work with just simple substitution. Likewise, on this one, if we let u be x squared, it's going to be 2x under du, and that'll cancel the x, and we will be able to do this one by simple substitution. And the next one, again, if we let u be x squared, we'll get a 2x underneath the du, and the x will cancel, and this one can be done by substitution. This one doesn't look very promising, so I'm going to work on this one, see it a little bit here. I'm going to say, let's see if substitution helps it. We let it be the 4x plus 1. Du would be 4 dx, and dx would equal du over 4. So this would become the integral of 1 over u to the 1/2, and dx becomes du over 4. The fourth comes out. This is u to the negative 1/2. And you can integrate that, and so substitution is all we need for that one. Okay. Number 2. Use integration by parts to evaluate the integral. So they don't want us to do substitution or anything like that, so let's go ahead and do it by parts. And my little table for that. F prime u v u, I think, will work to be the 3x, although we can pull the 3 right out, but I'll leave it in 3x. And the derivative then would be 3 dx. And for v prime, it'll be cosine 4x dx. The antiderivative would be sine of 4x. But taking the derivative, that would produce a 4. We don't have a 4 here from the chain rule, so we'll put 1/4 to get rid of the 4. So this would become the antiderivative of, uv, 3x times 1/4 sine 4x minus the antiderivative of, 1/4 times 3/4 can be pulled out of the integral, and then we'd have sine 4x dx. And you could do u substitution for the 4x, but we know how to integrate that, and so we get 3/4 x sine 4x minus, we got 3/4, but to integrate sine, we're going to get negative cosine, which will make that be plus cosine of 4x, but the derivative would produce an extra 4, so we have to have a fourth times the 3/4, so it's 3/16 plus c. And e to the 8z, I don't know what the 8z has to do with anything, but we can do it by parts here. Let's let u equal the z plus 1. So du would be 1 dz. And v then would be e to the 5z dz. Integrating that, we're going to get the derivative produces a 5, so the antiderivative has to do a 1/5 e to the 5z. So it's uv, which is z plus 1 times 1/5 e to the 5z minus the antiderivative of these, which is a 1/5 e to the 5z dz, and the antiderivative of this we already did. It produces that 1/5 this times 1/5, so we're going to get 1/5 z plus 1 e to the 5z minus 1/5 times a 1/5 is going to be minus 1/25 e to the 5z plus c. And on this one, again by parts, we'll let we'll do let the t go here, and then this would be 1 dt. So they'll put e to the minus t dt. The derivative would produce a minus, and so the antiderivative produces a minus e to the minus t. Minus e to the minus t. So this becomes uv, which is minus t e to the negative t minus the antiderivative of these two, and that minus will make this be plus, and it'll be e to the minus t dt, and we just integrated that already once, and so that's going to be minus t e to the minus t plus a negative e to the minus t plus c. And there's e to minus t, so sometimes people will pull out there's a minus in both of these, and an e to the negative t in both of these, so we might go minus e to the minus t. We pulled out the minus, that leaves a t there. We pulled out the minus, that leaves a 1 there, and it would look like that. Okay. Number 5. Determine f prime. So f looks like this, and we have to find the antiderivative from there to x. Well, f prime would be take the derivative, and we've already talked about that. F prime would be the derivative of, with respect to x, of this, which means all you have to do is put an x in place of the t's in this as long as this is just x. So it becomes t e, or x, t becomes x. So x e to the minus 2x. And the derivative gets rid of the plus c, so there's no plus c. Now, find a formula for f that does not involve an integral. So f is from 0 to x, so it would be, it's the from 0 to x of this, which means we have to integrate this. And so to integrate that, we're going to do the antiderivative, or we're going to use integration by parts. So, and f prime, and so we're going to let u be t, and the derivative of that would be 1 dt. We're going to let this be e to the minus 2t dt. So the antiderivative of that would be negative 1/2 e to the minus 2t. So we're going to have the integral from 0 to x of f of t dt will become this, which is t times negative 1/2 e to the minus 2t minus the antiderivative of these two, which is a negative 1/2 e to the minus 2t dt. So we get minus 1/2 t e to the minus 2t, and then when we integrate that, we get another minus and a half, so it gives minus 1/4 e to the minus 2t, evaluated from 0 to x. So the first fundamental theorem of calculus says put the x in, and we get that worked out, and we get all of this. Let's see, I'll write it down here. Minus 1/2 x e to the minus 2x minus 1/4 e to the negative 2x, and close that up, minus, and put in 0, and we're going to get 0 times everything in this, so that's gone. And if we put 0 in here, we get minus 1/4 e to the 0, e to the 0 is 1, so minus a minus 1/4, which is plus 1/4. Now, just to confirm, that really is f prime of x, to make sure the constant is right. The f would have been, f of 0 would have been 0 to 0, so it should come out to be 0. So if I put in 0, this becomes 0, this becomes negative 1/4, plus 1/4 is 0. So, then it asks, is f an increasing or decreasing function when x is greater than 0? Well, we could graph it and see if it's increasing or decreasing. But also, if the derivative is positive, the derivative, which is this, f prime was this, if this is a positive number, that means it's got a positive slope or is increasing. So as long as x is positive, t would be positive. So the t would be greater than 0. And e to the minus 2t looks like this on a graph, and it's greater than 0. T is greater than 0, so it's going to be a positive derivative, so this has to be increasing. A little tough to look at that and really tell, but that tells us. Okay. Now consider the definite integral, the indefinite integral given by this. And to do this one, I'm going to kind of ignore this and talk about what this is asking, then maybe look at this. But it's we can do this one by letting u be e to the x in substitution, or let's call it w because I don't want to confuse it with the integration by parts u. So then dw would be e to the x dx, and so I would end up with e to the x under dw. So this becomes the integral of, so e to the 2x is e to the x times e to the x, because you add the powers and when you multiply and you get e to the 2x. So this is e to the x, which is w, times w, or w squared if you will. That's what this would be, e to the 2x, cosine w, and dx is dw over e to the x, which is also a w. So w will cancel one of the w's, and we'll have the integral of w cosine w dw. And that one works with integration by parts if you let the u be the w. So setting up the parts, f and f prime, the derivative. So this is, we're going to let w go here, so the derivative is just dw. And here we're going to put the cosine w dw. Antiderivative of cosine is sine. Derivative of sine is cosine. So this becomes uv w sine w minus the antiderivative of sine w dw, which is, this part here is just negative cosine w. So the negatives cancel, and so I get w, which was originally up here, e to the x, sine e to the x minus a minus, which is plus cosine of e to the x plus c. They said let z equal the x. I did w, but anyway, okay. So we end up with this. Evaluate the integral you found using the appropriate technique. That was by integration by parts, which we did. How is the problem of evaluating this different from the integral of doing before? Well, this one, if you let z be e to the 2x, the derivative is going to produce an e to the 2x, which is going to cancel, and we won't have to do the integration by parts. So that's how it's going to be different. And then do so, okay, so if I let z, I'll use z like they suggested, equal e to the 2x, dz would equal e to the 2x times the derivative of up there according to the chain rule, dx. So this would go under dz when I solve for dx. So this integral would become e to the 2x cosine of z, or z cosine z. But the dz will be, the dx here will be replaced with dz over 2z, or 2 e to the 2x, and the e to the 2x's, or the z's if you will, cancel, and we get 1/2 integral of cosine z. And the integral of cosine z is sine of z, and z was e to the 2x plus c. So we didn't have to do integration by parts on that one, because that completely canceled out with that being the u sub. On this one, it won't completely cancel out. Evaluate each of the following integrals, keeping in mind the approaches here. This one, we're going to let z equal e to the x, and then we're going to have an we're going to end up with z e to the sine z dz, and with a half in there, I think. Oh no half. And we'll have to do integration by parts. This one, they're going to cancel out and be pretty straightforward. It's just a third in there. And this one, it's going to, well, we'll see. So let's go ahead and do this one. If we let z equal e to the x, then dz equals e to the x dx. So this would become the integral of e to the 2x, or e to the z squared, because this is e to the x times e to the x, that sine z, and then the dx is dz divided by e dx, dz divided by e to the x, which is a z, and that cancels one of these, and we're going to have to do integration by parts, and so we're going to set up, we're going to put in z here, its derivative is dz, and we're going to put sine z dz, its antiderivative, this is v, it will be negative cosine z. So we're going to get the antiderivative, or no, we're going to get uv, which is negative z cosine z minus these two multiplied in the integral, but that's going to create a minus, which is going to change that to a plus, integral of cosine z dz. The antiderivative of that is just sine of z, so we're going to get z, or negative z, which is negative e to the x cosine z, and the antiderivative of cosine is sine, so we're going to get plus, it's not a negative, sine of z plus c. So that's this one. This one will be simpler. If we let z equal e to the 3x, dz will be e to the 3x times a 3 dx. So this would become the antiderivative of z sine z, and dx will be replaced with dz divided by 3z. The z's cancel. 3 comes out as a 1/3, so we get 1/3. The antiderivative of sine is negative cosine z, and z was e to the 3x plus c. And then this one. So this one, if we let z equal e to the x squared, dz will equal, let's move this up a little bit further, dz would be e to the x squared. Derivative of e to something is e to something times the derivative of something, and that something is x squared, so its derivative is 2x dx. So this becomes the integral of x e to the x squared, or z, or xz, cosine of z, sine of z, and dx is dz divided by 2x e to the x squared, or z. This part is that part, that x is that x canceled, and so we have the integral. There's a 2 that comes out as a 1/2, and cosine z sine z dz. And we can do a second substitution. I'll use w now for, let's say, the cosine of, no, look, we'll make it be the sine of z. It doesn't really matter, one or the other. So dw will be cosine z dz. And so this becomes 1/2 the antiderivative. Cosine z, it's not something we have here. Sine z is w, and dz is equal to dw over cosine z. Cosine z's cancel. The integral of w is 1/2 w squared, but w, this is 1/4, and w was z, sine of z squared, but z was e to the x squared. Now, this problem could have been done also by doing just one substitution. If we would have let z originally be, let's say, either sine of this or cosine of this, doesn't really matter, but I'll make it be the sine, since it's a little easier to do the derivative of sine than is cosine. You don't get a negative. E to the x squared, then dz would have been, derivative of sine is cosine, times the derivative of the inside, which is e to the x squared, times the derivative of the inside, which is 2x dx. So this original problem, this 2x e to the x squared cosine e to the x squared, all of this will be canceled when this goes under the dz, and we'd have the integral of z dz, because dz is all of this, which is all of that, and the dx, and that's the z, and the integral of that is 1/2 z to the 2 plus c, so it becomes 1/2 z squared plus c, which is the same as what we had over there. So could have done it with one substitution. Okay, moving on. Number 7. Okay. So for each of the following indefinite integrals, determine whether you would use u sub, integration by parts, neither, or both to evaluate this. In each case, write one sentence to explain your reasoning in the statement. If you decided to do finally, use your chosen approach to evaluate the integral. One of the following problems does not have an elementary antiderivative, and you are not expected to actually evaluate this integral. This will correspond with the choice of neither among those given. So one of these is the neither. Okay? So here we go. Well, if I let u be x to the third, it's going to produce a 3x squared under the du, if I let u be that, and that's going to cancel the x squared. And so this is just going to be a simple u substitution. So du is going to be 3x squared dx. So this is going to become the antiderivative of x squared cosine u, and du is going to be, dx is going to be du divided by 3x squared. The x squareds are going to cancel. You're going to get 1/3 the antiderivative of cosine, which is sine of u, and u was x to the third, plus c. Okay? This one, I think I'm going to have to do parts after I do u sub. Well, I'm going to use the same u sub here, so I've got that set up here. So this is going to be the antiderivative of x to the fifth cosine u, and dx is going to be du divided by 3x squared. So x squared is going to cancel 2 of these 5 and leave 3 of them, and x to the 3 is u. So this is going to be a u. So I'm going to have the integral of u cosine u with a third, and the x squared is canceled. So this becomes then an integration by parts. So this is a both. And now to finish this, I'm going to let the u here be u, and so I'm going to get du, and the v is going to be cosine u du. The antiderivative would be sine of u. So this becomes 1/3 of uv, which is u sine u. I'll just call this w so that it doesn't get confusing. So the wv is these, minus the antiderivative of these two, which is sine u du, and that becomes 1/3 u sine u minus the antiderivative of that is a negative cosine, so it becomes plus cosine u plus c. And that third works on all of it, but I can just put it to here, or multiply a third here, and a third of the constant is just a different constant, so it's still a constant, an unknown constant. Okay? 1 second. Okay, the next one. Well, if I let u be x squared, I'm going to get ln x. And ln x, the derivative is going to produce an x. It's going to cancel the x, but I'm still going to have ln, which is integration by parts. Question is, could I do this one by integration by parts only, by letting the u be that? So let's see if that will work. So if I set up integration by parts, and if we're doing integration by parts, ln of something is what we usually put in here because we don't like to do the antiderivative. So we get ln x squared. So its derivative would be 1 over x squared times the derivative of the inside, which is 2x dx. Now, if we do all of this dx, all of this is the u, then x dx goes down here. The antiderivative is 1/2 x squared. Okay, so let's see what this looks like now. So this would become uv, which is 1/2 x squared ln of x squared minus the antiderivative of these two multiplied. Well, 1/2 times the 2 cancels, and this becomes x over x squared, or just one of those will cancel, so it would be just 1 over x times x squared, so that'll cancel another one, so it'll be just minus x dx. So this is going to work with just substitution, just integration by parts. It could have been substitution and then integration by parts, so it could be both, but by parts we'll do it. And we will get 1/2 x squared ln of x squared minus, and this would be 1/2 x squared, the antiderivative of x, plus c. This one, if you let u be x to the 4th, you're going to get a 4x to the 3rd in a denominator here when you replace dx, and that's going to make this look messier. And this is the one that they have starred for neither. Something we'll perhaps get to later. This one, the derivative will produce a 4x to the 3rd, which will cancel the x to the 3rd. So just a simple substitution will get this one going here. If we let u be x to the 4th, du would equal 4x to the 3rd dx, and so this becomes the antiderivative of x to the 3rd sine u, and the dx becomes du over 4x to the 3rd. The x to the 3rds cancel. We get 1/4. The antiderivative of sine of u is negative cosine of u, but cosine u was x to the 4th, so x to the fourth plus c. And this one, I think we're going to get both. We're going to use that same substitution here to get this out of the way, and then we're going to do it by parts. Or we might be able to do it just by parts if we let this whole thing be u. Let's see if that'll work. It will work substitution and then by parts, but let's see if it'll work with just by parts. So I'm going to set up this way. Put the sine of x to the fourth in here. So its derivative is cosine x to the fourth dx, but then I have to do times the derivative of the inside, which is 4x to the third. And v would be the x to the seventh dx. Its antiderivative would be 1/8 x to the eighth. So this would become, this may not be working. Let's see here. We'd get uv 1/8 x to the eighth sine of x to the fourth minus the antiderivative of these two, which the 4 times an eighth would be just a half. The x to the third times x to the eighth is not going to be pretty. That's going to be x to the 11th cosine of x to the fourth dx. This got worse. So we wouldn't want to do that. So if we switch these two originally, that might have worked, but let's not do that. Let's go to what the more obvious one would be to let do a z substitution for x to the fourth, like we did here. So dz would be 4x to the third dx, and dx would get replaced with dz divided by 4x to the third. So this problem would become the integral antiderivative of x to the seventh is x to the third times x to the fourth. I'm going to do that because I can see the x to the third is going to cancel. Sine of x to the fourth, but that's a z. And dz is over, dx is dz over 4x to the third. The x to the thirds cancel, and this becomes a z. So I have the integral of 1/4 of the integral of z to the z sine z dz. And we've done that several times, but by parts we can let the z be here and sine z dz go there. The derivative here is dz. The antiderivative here is negative cosine z, and this becomes 1/4 of uv, so that's minus z cosine z minus the antiderivative of these two multiplied, and that has a minus, so that makes that plus cosine z dz. And so we have 1/4 negative z cosine z cosine z plus 1/4, with that fourth distributing, cosine of z, antiderivative is sine z plus c, so it becomes minus 1/4. Z was x to the fourth, cosine x to the fourth plus 1/4 sine of x to the fourth plus c. That did show that. Okay, good. I think it might be possible if we'd put the sine there for the fourth and x to the seventh there, this may still have worked, doing it just by parts. But anyway, that's the idea from this assignment.